if you haven't already, it'd be great if you go onto the website shown here to download the manual. And you can also view the introduction webinar if you weren't involved participating last week with the introduction webinar. You can view it on YouTube, and today's webinar will also be on there. You can either hit the link or search for Lake Champlain Basin Program YouTube, and they've got all the webinars up there. So today we're going to focus on Chapter 2. It's some of the case studies that are included in that chapter, but especially kind of going through all the different types of green infrastructure practices that might be appropriate for the street environment. As a recall on what we talked about last week regarding what green infrastructure is. Well, it's an effort to mimic natural hydrology by essentially capturing runoff before it really becomes runoff. So capturing stormwater as close to the source as possible and infiltrating it into the ground, and hopefully filtering some of the pollutants out of it at the same time or prior to infiltrating it into the ground. So that's really our main goal with these practices that we generally clump into the green infrastructure category. So why would we want to do this for street runoff? Well, it happens that streets are especially tricky. They have a lot of runoff because it's a large source of impervious cover in a lot of our communities, and they have quite a few different types of pollutants coming off of them in that stormwater runoff. We're talking about oils and components of asphalt that would generally be called hydrocarbons. We're talking about nutrients, nitrogen, phosphorus, and others, and also, unfortunately, a lot of trash. In the winter time, you have a lot of salt. In the fall, you have a lot of leaves. So there's just a lot going on pollution-wise in street right-of-ways. And just like any other dark impervious cover, streets get hot in the summertime when the sun shines on them, and that heats up the stormwater. So we're also dealing with a temperature as a type of pollutant getting into our streams and waterways. There, however, are lots of opportunities to implement green infrastructure within the street environment, specifically for municipal governments, because streets and roads are the largest category of impervious cover that a lot of municipalities have ownership over. There is public right-of-way, usually not only in the area that has asphalt, but also to the sides, whether it be where there's a sidewalk or green space along the edges of the street. And in some cases, like in the picture on the bottom here, let me try that again. Right here you'll see a picture of a very wide street. So if your community has some of these very wide streets that happen to also not be very busy, then that might be an open opportunity for using this space to control some of the runoff that's generated by that asphalt. Also, on some of those wider streets, there tends to be faster traffic and therefore a need for traffic calming. So one of the neat things about some of these above ground green infrastructure practices is that they can serve as traffic calming devices. Also, street right-of-ways and street corridors tend to be a place where municipalities like to have some kind of landscaping amenity. So there may be opportunities in some cases to combine the landscaping goal with the stormwater management goal. And of course, even though it's one of the places with the biggest, the largest number of opportunities for green infrastructure from a public property standpoint, it also happens to be one of the most challenging environments to implement green infrastructure in. This is, in the picture here, this is a street bioretention that is under construction that I saw near San Francisco. And you can see, for example, in this picture how complicated it gets in terms of utilities. You can see all those utility boxes within the bioretention cell. That's I imagine that was just beginning construction. They've got the hard edge built, but haven't really gotten into all the soil and vegetation at that stage yet. One of the challenges of streets is that you have to get the runoff off of that street quickly. So it needs to be able to drain well, that just for safety wise. And I mentioned utilities, but also generally limited space within the street corridor is a very true reality with all the competing uses, not only just car traffic, vehicle traffic, but also parking, bicycle lanes in some cases, and then of course pedestrian uses. They have to work around all that. And in the same situation that I saw in San Francisco, I looked into one of the delis and it said parking bad. So, you know, there's certainly a lot of preparation that needs to be done in terms of dealing with the public and having contingency plans for parking during construction of green infrastructure practices within the street corridor. We have expectations that we can easily park and get to where we need to go, and when you have a very busy street, that needs to be very well orchestrated. We have lots of options, different types of options within the green infrastructure realm, within the street environment. Some of them are below ground and some of them are above ground. So we're not only, in this webinar today and in the manual, we not only talk about above ground vegetated practices, but also the below ground practices. But for now, I'm going to talk about these 4 above ground options. Streetscape bioretention is a general term to describe a system, a cell, if you will, that will take in stormwater via some kind of inlet directly from the street and then pond it in the cell and allow some of that, some of the sediment that comes off of the street to settle down to the bottom, and then allow some of the vegetation to soak up the water. Some of the water will infiltrate down into the soil below the bioretention, and then some of it will also evapotranspirate into the air as the sun shines on it over time. And, there's some ponding water in that cell, and it will evaporate a little bit. Some of these streetscape bioretention systems also have underdrain pipes down in the stone reservoir. This diagram, which comes from New York City, does not show an underdrain pipe, but it does show about 2 feet of engineered soil below the surface, and then a pretty thick stone bed. I would say it's probably maybe a foot or more under the soil, and that stone bed is what holds a lot of the water while it slowly infiltrates into the native soil down below. Here's an example of another streetscape bioretention system where in the previous slide you'll see here that the inlet is a curb cut through the sidewalk curb. But here, the inlet is actually a grate, a drop inlet or a catch basin that catches the runoff from the street, and then through a pipe that goes onto the curb lets water into the bioretention system. And in this example, you have these little weirs that are made out of concrete that slow down the water. So downhill is going in the direction of my mouse there, and this first cell fills up with water and then spills over into the next cell. So they kind of act like check dams to deal with some of the gradient on that slope. But I would say in general, these are best on fairly flat streets. Another thing that's unique about this Streetscape Bioretention is that they've decided to put the tree outside of the cell rather than inside of it, like in the previous slide. Here you see that the tree is within the bioretention, and you know, there are various reasons for that. It could be that the tree was already there, or they just want to avoid having those big roots, or probably trying to avoid all the shading so that these plants that are lower don't get shaded out. It's important to think, of course, about maintenance when we build any type of green infrastructure. What's kind of interesting about these above ground practices that have vegetation is that, you know, any municipality is going to need to maintain their landscaping practices fairly frequently. So that's not anything really different with, say, this bioretention, but instead of, for example, the maintenance involving a lot of watering, regular watering perhaps, this would require more trash removal, for example, because they do catch trash from the street. So instead of that trash going into your storm drain system directly, it's getting collected in these open bioretention cells and needs to be removed. Also, sediment collects in there, so that will need to be removed as part of your maintenance regime. Yeah. Oh, and Dave here was reminding me that that's a good segue into mentioning that next week we'll have an operation and maintenance workshop in Plattsburgh, New York. So take a look at the LCBP website if you're interested in signing up for that, and I'll show you the link to that at the end of the presentation as well. All right, here's another example of, I would say, component-wise is very similar to a bioretention system. It's a swale that one of the biggest differences is that it takes up more room. These are usually wider. I would say they can capture more runoff. So they really are only appropriate if you have a road with a large shoulder on the side of it, or a fairly wide right-of-way. They may or may not have an engineered soil below the surface. Some are built just to capture the runoff and let it percolate down into the native soil, and some are constructed where more soil is scooped out and replaced with a sandier mix that allows faster infiltration. You'll see here also that the plant palette is fairly different. It's a little bit more wild and woolly. You know, it might be a good, one of the advantages, I would say, is that you might not have to maintain it quite as often as you would something along a sidewalk, because you can allow plants to grow a little bit larger and maybe use equipment to maintain it versus just hand weeding. So this is another example that uses big stones and small stones to create check dams. And the reason they have these is because this swale is built on a bit of a slope, and they needed some kind of control structure to slow that water down and let it pond, rather than just zooming down the swale and causing erosion. Here, this next practice we generally call tree pits. That might be called lots of different things, but in the manual we call them tree planting or tree pit practices. That in some cases they're not all that different from some of the street bioretention images I showed earlier that had trees within the bioretention system. But one thing to note that does make them a little bit different is that they're almost always used in highly urban areas where you have a significant sidewalk next to it, and you have, of course, the concern of tree roots and how to deal with big tree roots that grow outward. So in this example, they've have a fairly decent, let's see if my cursor works here, fairly decent volume downward for the roots to grow downward. And then also a stone reservoir down below. So again, not all that different from bioretention. Here's a tree pit system that is a proprietary system called Filterra, and they what's kind of interesting and unique about these is that they're actually connected to the existing storm drain network. The inlet right here, that slot, is just like a regular, inlet curb cut, or rather catch basin that you would see along a lot of roads. And inside, down in that catch basin, it's full of an engineered soil that has a lot of sand in it. So fast infiltration, it really acts like a filter. The tree is there to kind of soak up some of that water. But again, it's in line with the storm drain system. Instead of, let me go back to this slide. It's a little hard to tell here, but it doesn't look like this type of tree pit, for example, has any kind of underdrain or overflow that sends water to the storm drain network. Another style of tree pit includes something called structural soils. Now, since a lot of you are from New York, you may have actually heard about this. It was developed by a group at Cornell University. The person I'm most familiar with who's worked on this is Nina Basuk, who's with the Urban Horticulture Institute there. And what structural soils really are a type of medium that can allow a tree to get the nutrients and water it needs from the underlying soil, but also has the structural capacity to hold up a sidewalk. It can hold that compaction and loading that's required to build a sidewalk on top of it, on top of the root zone without damaging the tree. So it looks like this when it gets manufactured and arrives on site. So you see it's got the big gravel, big kind of angular stones. I'll go back to this image here. The stones are very angular so that they kind of lock together. And in the holes that lie between all those stones, there's soil and air. And that allows for a place for the water to go and provide some aeration for the roots. So here's a cross-sectional detail of how you might implement the use of this type of soil, structural soil. It's probably a little bit small on your screen here, but and you can also go on their website to download this. Here you have the structural soil kind of around the root ball of the tree that gets planted. To the left, you have a sidewalk here that's regular poured-in-place concrete. Okay, I'm sorry, I just said that wrong. The planting soil is what's around the root ball. So you actually plant the tree within regular planting soil, and then the structural soil goes under that. That's what is holding up the sidewalk to the left. But the nice thing is that it enables the roots to grow out of its regular little planting soil box, which is most typical of what you see in the cities, and gives the roots more room to spread out into the structural soil. So it allows the tree to really grow bigger and stronger. And this cross-sectional detail also has a drainage pipe that is tied to the storm sewer, so that if you have a lot of rain collecting down in there, it has a place to escape and not flood the street. And here's just an example of trees in Ithaca, New York, on a pedestrian mall, and they look good and healthy, but they've also are surrounded by sidewalk and lots of hard structures. So it's a nice way to marry those two purposes. One kind of out-of-the-box idea that you might clump into the green infrastructure realm is stream daylighting. And I guess out-of-the-box is maybe a literal term here, because the stream daylighting refers to taking streams that have been piped as a city has been developed or a town has been developed, and bringing that stream back into the daylight, exposing it to all the residents that live there, and essentially taking what was a dead system, because aquatic invertebrates and fish cannot live in an underground pipe. So you're reviving it, exposing it to the sunlight and to the elements. Okay, let's talk about below ground structures very quickly. First of all, infiltration practices. What we, there's infiltration is happening in pretty much all of these practices, but there are some practices that are underground that their primary purpose is just to infiltrate. There's no vegetation involved. So this is most appropriate where you have not very much space, or you just don't want to have something kind of competing for space. So this example here is in Syracuse, New York. On the upper picture, you see a regular looking street with lots of trees. So one thing that might have been in the decision-making process is that they don't want to have to cut down trees to put in a stormwater practice. So they decided under the street to put this infiltration system. There's a regular inlet here where the street runoff goes into the inlet, and down underground you have lots of storage space in a solid pipe on the right and a perforated pipe on the left. So the water comes in, the sediment kind of settles down into the bottom of the catch basin, and then the water kind of percolates out into through the perforated pipe down into the native soil. Another advantage of this type of practice is that you probably can hold and capture a lot more water than you would from a small street bioretention, for example. Another practice that I guess you could say is above and below ground is permeable pavement. They are often, permeable pavement, I use that term to talk about pavers, like what you see in this picture, so individual pavers, but also permeable asphalt, permeable concrete, which is a solid form type of permeable pavement. They are often used in kind of low traffic areas or parking aisles, places where you generally don't have as much car impact and heavy loads. But they can also be used for heavier loads. This is an example in a facilities management facility at a university where they have a lot of heavy trucks coming in. These are pretty sturdy interlocking pavers here with a really thick subbase of gravel underneath. Essentially the water goes in between the cracks there, in the spaces in between the pavers, and goes out down into something like a foot or a foot and a half or more of gravel. So it's got lots of pore spaces for that water to travel into, and then from there it slowly soaks into the underlying native soil. Here's an example from Lake George, New York, Beach Road, right along the edge of the lake. Very, very busy area in the summer, especially with lots of tourists and visitors coming. They had a massive revamping of this street corridor where they had a very, I would say, heavy-duty use of permeable asphalt. Here's a cross-section of that practice. It's got kind of a porous asphalt system on the top that's, you know, regular 3 inches. It has fairly small air voids on the top layer, and the air voids essentially get bigger as you go downward. The 6 inches under that top layer, it has a 20 to 25% air void, and then there's a choker stone layer below that to keep sediment from traveling down into this really thick stone reservoir layer that's almost 2 feet thick under that. So, you know, highly engineered, but this is an example of how high traffic areas can also use permeable pavement. Now, you might wonder, how do you treat permeable pavement differently from regular pavement? Well, you do need to keep sediment off of it as much as possible. Well, you're not going to keep it off of it, but you need to remove sediment fairly frequently. So vacuum trucks that clean streets are used for this type of practice. On the left, you'll see that there's what we call preventative maintenance, which would be routine maintenance to get fine silt that's right on the top layer. That usually uses a lower suction, lower strength suction than you would if, for example, you had a permeable pavement that got really filled with sediment and you needed to replace those that little bitty gravel that's in between the pavers. So here on the right, they've used a really high suction, and they've actually removed the filler stone, and then they will replace it after that. So hopefully by doing preventative maintenance at a lower power suction, you can avoid having to do restorative maintenance. If you've got, you know, here's a sidewalk where you're not going to be able to put a full-size vacuum truck on top, they do make these smaller vacuum trucks, vacuum machines as well. So in this picture you see it's both sweeping and vacuuming. So when you design these things, you kind of have to think about what equipment you have available to maintain them. So if you have this alley, for example, that's quite narrow with permeable pavement, you have to hope that they designed this with the knowledge that they will have the equipment, or they do have the equipment that's small enough to get into this back alley to maintain it.
They didn't in that case.
Oh, and Dave says that in this situation they did not. So I guess that was a problem. They're thinking about what's the next best option. So this is more of a filtering situation versus an infiltration situation. Some of these underground practices that are proprietary, they come in many different forms, but a general category of these underground filters is called hydrodynamic separators. And water comes in on the left side, the left pipe here, swirls in a vortex pattern down into the bottom of the catch basin, and this allows sediment to settle down to the bottom and then get vacuumed out on a monthly basis or so. The nice thing about these is that they also separate out trash into the upper part, so that can also I'm sorry, the water comes out into the upper part and then goes out from there to your storm drain network. And here's just an example of a hydrodynamic separator combined with an infiltration system on the right there, where you see those yellow infiltration storage units that allow the escaping water, the cleaner water, to get infiltrated into the ground. So these can be used in combination with different practices. In terms of the benefits of these practices, there's myriad benefits, but some of the practices I talked about here, bioretention, I discussed how there can be a traffic calming effect and, of course, a landscaping aesthetic effect. Tree pits allow for shade and cooling while also serving some of your aesthetic and landscaping needs. Swales can be used just like bioretention, streetscape bioretention practices. They can be used as barriers between cars and pedestrians or cars and bike lanes. And some of those underground practices can catch sediment and trash and kind of localize them so that they can be removed on a regular basis rather than going straight downstream. And one of the unique things about permeable pavement is that you actually, in most situations, improve the safety aspect by having less standing water on the surface where cars are passing because the water goes directly down. And of course, in the cold climates where you're putting down salt in the wintertime, one of the interesting things that the University of New Hampshire has found is that there's reduced need for repeated applications of salt because those pores in the permeable pavement hold on to the salt for longer periods of time. It doesn't get washed off of the pavement as much as regular asphalt. Okay, that wraps up my section, and I wanted to see if there are any questions that have come in. I'm just going to take a look at the chat box here. If you do have any questions, go ahead and type them into the chat box there. And if none come in, we will just go on ahead to our guest speakers. Okay, well, it doesn't look like we have any questions from a few minutes back, so we'll go ahead and move on to our guest speakers, and still feel free to put a question in there, whether it be for me or our guest speakers, and we'll try to address them after our guest speakers are finished speaking. All right. Looks like I'm having trouble, Ryan, getting to the next slides. Okay. All right. I just wanted to introduce our guest speakers before they start. We've got Jim Lieberman, who is a district manager at Warren County Soil and Water Conservation District in New York. He's been with the Soil and Water Conservation District in Warren County for nearly 20 years. He wears several hats in his position there. He's also the Warren County Stormwater Management Officer and the Stormwater Management Officer for the town of Queensbury. And in his work, he's presented many programs on stormwater management, erosion and sediment control, even in invasive species and fish and wildlife. So he's got a really well-rounded background, and you'll be in great hands hearing him speak about some of the stormwater management practices he's implemented in his district. And presenting with him on a couple of these practices is Tom Jarrett. He is a licensed professional engineer in New York State, and he has 40 years of experience in the civil and environmental engineering realm. He's owner of Jarrett Engineers, which is based out of Glens Falls, New York, and he has a broad array of experience from wastewater engineering to stream corridor designing to stormwater design. So you'll get to hear a little bit of his expertise. So please welcome, Jim and Tom. Thanks for helping us out today.
Yeah, thank you. Thanks for having us. So again, we're coming across okay?
Yes, you are. Might try to get a little bit closer to the mic if possible.
All right, will do. All right, so we just moved the mic and get started. I just like to thank you for having us here. And the initial slide that we have is an introduction. That's actually English Brook, which is one of the main tributaries of Lake George, and enters at the village of Lake George and town of Lake George municipal boundary down at the lake. This plays a big role in a lot of projects that go on around here for a variety of reasons. And actually, if you notice, there's a bunch of flagging downstream of this, and that's because we actually did a project at this site. We didn't include it in this, but it was at the request of the New York State DOT. The former resident engineer had contacted us, and instead of just pouring rock over that bank, which you see, which is raw, that's from Hurricane Irene. On about 15, 18 feet away is Route 9, State Route 9, so he was concerned with losing more road bank there. We actually did a natural stream design with Trout Unlimited. So there's a lot of practices that go on that people, the general public, don't even realize are going on or would be considered a green or soft or bioengineering type of project. So, you know, one of the big things, and I think Tom will second this, is that in his projects and our projects, we look at encouraging alternative ways of looking at things and incorporating maybe less gray infrastructure and including more green infrastructure. So this works out very well. So a little background for those of you who are not familiar, that's just an image of the Lake George watershed. It's almost 150,000 acres. The lake is 26 miles long, 3 miles wide. It's widest. It's an amalgamation of overseers. There's 15 municipalities, 3 counties, 1 village, 12 towns, and all the green you see are New York State lands. There's 9,500 permanent residents, and that increases to 36,000 in the summer. I closed my window because if you didn't, you'd be hearing some of those visitors because we have a Americade, which is a huge motorcycle rally, and there'll be 75,000 motorcyclists here this weekend. Year-round housing has increased from almost doubled from 2,800 to 5,000 in 40 years, and we have nearly 400 miles of roads in the watershed. The area that we're going to be talking about is circled in the blue on the map down on the south end of the lake. If those of you are not familiar with it, Lake George flows from south to north. Probably once a month, somebody will say, I didn't know, I thought it flowed to the Hudson River. So whenever we can provide some education, we do. So, you know, why are we so concerned with stormwater management in Lake George? Well, we deal with stormwater management all across the county. However, Lake George is a little different. It's a AA special water body, drinking water source. Unfiltered drinking water is the highest standard that the DEC has. There's a number of oversight agencies, the Lake George Park Commission, the DEC, Park Agency, Army Corps of Engineers, the municipalities I mentioned, plus others. In the past 30 years, the sodium level in the lake has doubled and the chloride levels has quadrupled. So there's some concern there with health issues down the road. Overall, Lake George is still in relatively good health, but you know, when you start that stone rolling down the hill with accumulation of nutrients and chlorides and such, then it's concerning. We do have zebra mussels, we do have Asian clams, and kind of the typical other invasive species that you'd find around here, all of which are, there is a program that's looking to address it. We don't get into it, but I know both Tom and our office have been involved in meetings and presentations and showpieces of the area looking to reduce the usage of salt and chlorides from the municipal forces. And it's encouraging to see the, I'd say, the level of support that the towns and the county we have over here in reducing salt impacts. And it's exceptionally important for us because Warren County, you know, there's a huge amount of tourism, second home ownership, so there's direct economic impacts. There was a study done 5-6 years ago that showed $60 million impacts, I think, all the way up to Lake Placid from Lake George. So we want to keep that water quality high. And an excellent figure is down at the bottom. The house on the left, that's the 20,319. That's the average per acre residential outside of the Lake George watershed in one of the municipalities. So the town of Lake George, if you are in the town and you live outside of the watershed, that's what your assessed value is per acre. The middle, 67,644, is if you are inside of the watershed in that municipality, but not on the lake. And the 719,000 is the assessed value of the shoreline parcels. And that's an average across the entire watershed. The Lake George Association, Park Commission, DEC, Regional Planning Board did a study, and this is one of the findings that they drew from it. And that just shows the economic importance of our resources, and Lake George in particular. So one of the projects that we were asked to present on, of course I spelled it wrong in the map, but the Stormwater Basin, yeah, I spelled it wrong there too. There's an existing stormwater treatment pond for the northwest section of the village of Lake George, and that's where the yellow marker is. The village of Lake George is an independent municipality, highly developed. It's an MS4, Municipal Separate Storm Sewers community. It's not very large, and I think there's about 1,000 people that live there year-round. As you can see, that image just to the north of that image, that's a lot of hotels. That's what you're looking at. There's schools, businesses. So it's critical that the village has taken a lead role on protecting Lake George, which is their livelihood. So the stormwater runoff from the road right now, I've drawn in on the red, goes down to an existing stormwater basin, then flows in a closed system to a vortechnics filtration system, and then out to the lake. The purpose of this project was very simple. It's basically to try a product which the Village of Lake George Department of Public Works have not utilized. It's something that we've seen, and this is one thing that we as an office try to do, is if we can get a new product utilized to give it a test run, then we do. And that's basically for the benefit of the municipalities. By doing this kind of approach, these small, you wouldn't even think of it would be important, but it really gets the buy-on from the local communities to try green infrastructure, to try softer projects. The impetus of this was the village was starting to install some catch basins to collect stormwater in that area that I have marked in red, and put it into the stormwater treatment pond. But originally, right where you see the permanent gridding there had been about a 3-foot deep head cut in the soil that ran down to the pond. So not only did you have a little treatment that was going down there with a smaller existing outlet, you are now potentially increasing the flow into there significantly with more volume and velocity. The village asked for some assistance with some funds up above, and we said, sure. And would you be willing to try a different type of outlet material rather than our typical rock, which never gets maintained and ends up looking horrible, and except for the sediment that it captures, there's no nutrient uptake. So the village said, sure, that's great. Most municipalities are like, hey, if you can afford to purchase the materials, we'll try it. So it's a low-risk site. One of the advantages that you do have nutrient uptake by the plants when they come in. They'll have to potentially mow it. The challenging part, one of the challenges at this site is there's about every invasive species in this stormwater pond treatment area except for Phragmites. But there's a lot of Japanese knotweed. You can see that there. But if you're not familiar with this type of material, I put in there the trade name, but you have to first install a permanent rolled erosion control product, which is coconut matting and a double plastic mesh. That gets laid down first. Then the Shore Max mats are installed. You can have it on top of it, or you can just extend it down. The mats are about 2x3 or 2x4 in dimension. One person can certainly handle them, but it's a lot easier if you have two people. So a highway department, not-for-profit, or our office can certainly install something like this. There's little teeth or hooks on the bottom of these mats, and so when you place them on top of the RECP, it just grabs right in and it acts as a unit. Again, we use some metal staples on here to hold it in place. Most of the time when we do any kind of rolled erosion, we use biodegradable staples, but we wanted to use the metal on here. If you're really wondering what that stuff is, if you've ever seen it, it's basically the same type of material that bartenders stand on. It looks exactly like it, same thickness, and it allows the vegetation to grow up through here.
From experience, correct?
Yes, from experience, yes. I have been into a bar once or twice. So here we have a picture I took the other day. So this is the first growing season. This was installed last summer, and we were, yes, we were dry. I refuse to say drought. California had a drought. We were dry, but the vegetation's starting to come in. You can see the Filtrex socks that we have here in place are capturing the sediment, starting to stabilize. If you're looking on the picture on the right, is going up the hill. In another year or so, this is going to have a lot of good grasses growing on it. I'm going to recommend to the village, though, that they have to go in there and do something about the Japanese knotweed. It might just be manual cutting, which I know isn't the best or the most effective, but there is some shading issues. But this is looking from the top down. The image on the top left was during the installation, and the image on the lower right was last week. And so you can see that vegetation is really coming in. They did have to put some rock on the top. They actually had a failure on the top, not of the system, but we had a big rainstorm, and there was unconsolidated material. And so they put some rock there. I believe that the Lake George Association is working with the village, and it's a school bus garage, and they're going to be pulling a significant amount of this top material out and part of the macadam out, and placing porous pavers there for infiltration, because basically it's a little used area where they might park some lawnmowers and things like that, and then push snow in the wintertime. So that would be an effective use. And again, this isn't the highest end type of practice, but our goal is to get the local highway departments, DPWs to buy into this. You start small and you start moving up, and that's basically you're generating working relationships, and you can show that you're effective at doing it. So small project, but it's paid a lot of dividends, and it actually rolls into this next project, which Tom and I are going to tag team on, which is the Exit 22 Stormwater Improvement Project. I guess I'll let Tom do the introduction, because he was the one of the initiators of this project that came to us. So I'll turn it over to Tom.
Thanks, Jim. As Jim mentioned, English Brook is a major tributary to Lake George, and it's impacted by not only Route 9 over several miles, but some town and village roads, as well as the Interstate 87, the Northway. There's an interchange at the north end of the village. Let's see if I get my cursor to work here. There's an interchange right where Route 9 and the Northway intersect, and there's an on-ramp at Exit 22. It's a circular on-ramp, and in the inside of that ramp is a DOT drainage structure that drains that ramp area to English Brook, and immediately upstream was another drainage structure that was a gutter system that dumped stormwater directly from Route 9 into English Brook. Let's go to the next. We'll come back to that in a second. The drainage structures I'm referring to, let's go to the top left photo here. One drainage structure is right here. That's the overflow from the inside of the ramp area. The other one, the gutter system, is right here above the ramp, meaning west of the ramp, and it took Route 9 runoff for about a quarter of a mile to the west and dumped all that runoff directly into English Brook. So this project entailed creating an infiltration complex inside the ramp area and diverting runoff from the old gutter system under the ramp with a new culvert and into this new infiltration complex. I'm going to go backward now and let Jim talk about some of the history of English Brook as it relates to this, to how much impact there is from the road networks on English Brook and on Lake George.
So we have a series of historic aerial imagery at our office, which if you're ever interested in looking, you don't have to come to our office. You can simply go to our website and pull up a key for the year and view it online. But besides that, a number of years ago, we started just looking at some of the areas, and English Brook is always one of the easier ones to find. The top image in 1948, you can make out a little bit of a delta being formed there, beyond what is along the lakeshore. And then in 1966, significantly larger. 2004 until what I stole off of Google Earth the other day, 2016. So, there's significant increase in Warren County in development post-war years. And whenever we do a watershed assessment, we kind of look at the real property to find out when construction was occurring. And it's traditionally or at regularity 35 to 50% of the construction in the watershed occurred in the period of the 1950s. So we have the Northway, which came through here, I think, in 64, 65. But it's not just the Northway. It's all the additional roads. It's the small road plus the next larger road plus the next larger road. It's just like stream orders. You have road orders, and they're increasing. And you have development. And before Clean Water Act, before realizing that there was such significant impacts, you have an expedited delta being formed. And in 1956, I believe, there was a small camp. You can actually see it down in here. This camp was actually built, I believe it was about 25 feet away from the lake shore. Now it's significantly farther away. The delta itself in the 2016 picture, well, the stream, Hurricane Irene changed the outlet, so the outlet now comes over here. The water, the depth of the water, you could walk out to here and be about 3.5 feet of water. Then you immediately drop off to 8, 10, 12, 14 feet of water. Boats get hung up in here where people have had too much sarsaparilla on an evening, and they beach it there. You have a significant increase in resident geese utilizing these areas. You have Asian clams setting up shop down here and spreading because there's some pretty good habitat there. And just the delta itself, it's estimated to be around 70,000 cubic yards. Now, if you really want to be truthful, this is part of the delta. This is part of the delta. I believe this is Army Corps wetland and Adirondack Park Agency wetlands. So, it's a difficult situation. And that's one of about 9 or 10 deltas that are in Lake George. It is not the largest. Hake Brook is the largest at around 80,000 cubic yards. So the local residents are very concerned about it. The municipalities are concerned. People who care for the lake are concerned because of the types of non-point source pollutants that enter the lake. So you can track these. You can track the growth of these deltas. And again, I realize that deltas are a natural formation. It's just we as humans have a tendency to speed things up. So going back to, I'll turn it back to Tom. Do you want to keep talking about the project? Do you want me to?
Oh, sorry. The project site that we are talking about is about 1/3 of a mile upstream from the delta, and as I said, it's the intersection of Route 9 and the Northway. We collaborated with a number of different groups, including Jim's group, who was very instrumental in this, and DOT and the village of Lake George and the town of Lake George cooperated as well. The first component was to, let's see if we want to jump ahead here. The first component of this project, and this slide just shows you the location again and the setting where this project is in relation to the lake and the delta. I'll jump forward here. I'm going to come back to that. Okay, the first component was to basically dig out this infiltration complex, and we left the culvert under the ramp unconstructed. We left it out of the project initially until we had this full area stabilized, dug out and stabilized. I'll come back to that in a second. What we did to size that area was look at the watershed. And there's approximately 8 acres of watershed that directly impacts English Brook at this area. And we incorporated a little bit of area downstream of the gutter leading into English Brook, so enlarged that watershed slightly. But you'll see here in this diagram a number of sub-watersheds or sub-catchments, as we call them. And we did a hydrologic analysis of the site to determine how much water we had to manage. We also did something a little bit unusual. We analyzed the site for frozen ground conditions. So it basically assumed no infiltration during the storm cycle, and tried to impound up to a 100-year storm if we could, and then let it infiltrate slowly over the next few days. We found during the project in constructing it, we found during constructing the project that we had shallower groundwater than was originally anticipated. We had to make the basins a little bit shallower than we really wanted to. So we do have a little bit reduced volume, but we still manage a 100-year storm during normal soil conditions. Now what you're looking at on this diagram, there's the culvert under the ramp that is brand new. The gutter that led to English Brook has been closed off. It is still available as an emergency overflow in case the culvert blocks off, so that we don't impact the state highways. But normally flow would flow through this culvert into a plunge pool. And that plunge pool is rock lined to dissipate energy. It diverts flow along the circular path through the system, and it diverts it to the northeast into a pre-treatment or settling basin to try to take out as much sediment as we can. Right now, the system is still relatively immature, so we're getting an awful lot of infiltration even in this basin.
Tom, I just want to be mindful of the time. We're going up on the 1 o'clock hour, so if you could, maybe like five minutes or so.
Yep, we can make this very quick. Yeah. All right, from there, it flows into this larger infiltration basin, very shallow infiltration basin, which is about 2/3 of an acre and gives us quite a bit of impoundment area for infiltration after a storm. We did create a new an emergency overflow back to English Brook in case this pond is breached during a storm that's larger than 100-year. But essentially, we're going to contain much of the storms, many of the storms that impact Lake George.
So just some examples, and again, I put these in because these are simple little things that the public notices. We got comments on. It doesn't seem like much. That was the original. That was material that was getting pulled out by the Village of Lake George, who did the majority of the construction. It's not good stuff to work with. And we actually were just cleaning out our hydroseeder, but it was dry. It was dusty. It's in Lake George. It's by the Northway. And so that actually, we didn't plan on using any hydromulch at all, but we used a tackifier to keep the dust down. And, you know, that's stuff that is easy to do. You can document it, and people are happy. The other thing we should mention is the village really wanted to do this project because, again, this is in their MS4 area, so they maintain it and have done a lot of work on it. So just starting with plunge pool and working in that wraparound through the grass waterway. This is during a significant rainstorm we had earlier this spring. That's what it looks like currently. That's the forebay that Tom was talking about. On the top left, the lower right is the shallow infiltration area. There's a better image of it. Basically, it was just some land grading that occurred. And well, that's the Exit 22 project, with the exception of, I give all the credit in the world to the Village of Lake George DPW for setting it up, because they managed to work with other communities, not in the Lake George watershed in our county, and they moved, I think, 5,000 cubic yards of material in 3 days to get this completed. They baled it up. We had these big mounds, and then they moved it. So it worked out very well. So this is getting a lot of good, I don't want to say press, but people off the street, people in the area, people who did not want it, now look at it and say, well, that's one of the nicest things I've seen in a long time. You know, so it was a good collaborative project. The last thing I guess I'll finish up with saying is I think that one thing that we have a tendency to overlook is when, you know, we're dealing with municipalities, I think it's important hitting the planning section of it and seeing what can be done for private landowners, because we did a quick assessment in the Halfway Brook watershed, which is part of the Champlain Basin, and in the town of Queensbury. Out of the impervious surfaces that are identified by the Basin Program's GIS layer, 2/3 of those impervious surfaces are actually privately held versus the municipality. And the municipality always gets the, you look what your road is doing. Well, there's a significant volume of water coming off of private lands impacting what the municipality has to do. So, just some other projects that are going on here: the rain barrels, porous pavers, vegetated swales. Low, I don't want to say low technology, but easy fruit to pick off the vine and get completed. And that's why we do it. That's from the town of Lake George, partway up the lake looking north. So that's why we do what we do. And if anybody would like more information, you check our office out. Most of the, a significant amount of the background information is from the Lake George Watershed Data Atlas. And you can reach Tom Jarrett directly. So I'll turn it back over to you.
Excellent. Thank you so much, Jim and Tom. Jim has really implemented a lot of these interesting green infrastructure practices. So I hope you don't mind my saying it's a great idea to get in touch with him if you are thinking about implementing some of these practices in your locality. Some great examples from the Warren County area. All right. Well, as Ryan turns things over to me here back again, I've got just a few concluding slides. I just want to thank everybody again for coming and being part of our webinar today. I didn't see any questions come in, so since we're past the 1 o'clock hour, I will go ahead and just wrap up. There's a picture of Jim that I meant to show you guys earlier. So that's the guy to talk to at Warren County Soil and Water District. All right, just a few tips regarding planning and implementing these types of green infrastructure practices. And this is a reiteration from a few things I've said earlier. One of the unique things about streets is that they often get renovated or reconstructed or improved. So working in green infrastructure proves to be a little bit easier, I would say. There are more frequent opportunities to kind of work that GI into expected and scheduled improvements, at least in relation to, parking lots, for example, don't get renovated as often. So that is one unique thing about streets. In terms of choosing a practice type, what you'll really need to do is look at how much space is available, how the space is used in the street right-of-way, and what are the safety requirements. So those are just some of the many factors that go into that decision-making process. I would say, so in order to avoid safety issues, but also future problems regarding movement of traffic, throughout the whole process, it's really important to work closely with your transportation department, both during design and, of course, construction. Where you have really busy streets, as I mentioned before, it's a great idea to have some contingency plans for how pedestrians get around, how bikes get around what you're trying to construct, how to make up for lost parking during and after construction. So there's plenty of factors to think about there. And then maintenance sometimes gets forgotten, but if maintenance is part of the design process, planning out that maintenance regime during the design process can really help elucidate what the future should look like in terms of what the maintenance crews need to do. So coordinating very closely with those folks who are going to be maintaining both landscape practices and underground practices is very important. So just a few tips to end on, and I'm just going to look at the chat box. no specific questions coming in, but if you do have any questions for us in the future, we'll have our contact information on the LCBP page website, and feel free to get in touch with us. My last slide here, if I can get it to advance, is a little promo for our upcoming webinars. So next week we have an in-person workshop. It's not a webinar, but it's a operation and maintenance workshop in Plattsburgh, New York, June 15th. If you haven't signed up for that and would like to, get in touch through the LCBP page. There's a registration, a place to register there on the website. And then we have the 3 upcoming webinars will be on rural roads. So slightly different scenario than what we've been talking about here. These would be roads in less developed areas. Some of them are gravel, some of them are dirt, etc. And then we'll be talking on June 29th about parking lots and other hardscapes and how to deal with stormwater management there. And finally, July 13th, we'll be talking about green infrastructure associated with buildings. So here's just an image of the lcbp.org website, which you probably have already visited, but take a look at that website again if you want to be reminded of these dates. And we hope to see you or see your name at least at one of these future webinars.